Hey guys, this is Malinki. Welcome back to my channel Voice of Malinki. Today we will discuss about Lotka-Volterra model. And if you are new in my channel, please subscribe my channel. And if you like my video, please do like, comment and share my video. Let's talk about Lotka-Volterra model. So Lotka-Volterra model provides us information about competition between two species which are sharing an identical ecological niche. So two species, when they are sharing an identical habitat or identical ecological niche, there would be some competition. And about that competition, we will be able to know from Lotka-Volterra model. Without competition, no two species can share an identical niche. Therefore, if two species share an identical niche, there must be a competition between them. So, if the competition takes place between two species, two things can happen. So, one will win and other will be defeated. So, either these things will happen, one will win and other will be defeated. Otherwise, resource partitioning will be taken place, where one species uses a particular resource whereas other species uses another resource of the same ecosystem. Hence, there is no competition, they both can live together. So, I am giving an example of the resource partitioning. Okay, so suppose all the lizards located in a particular ecosystem eat insects. During the course of time, competition takes place between them. Then some lizards live on the forest floor while others live on the top of trees. Therefore, both of them will get their food from different areas within a same ecosystem. This is the example of resource partitioning. So, in this case, there is no any competition. But Lotka-Volterra model deals with the first condition. That means it deals with the competition where one will win and other will be defeated. Lotka-Volterra model is not at all interested with the resource partitioning. So, Lotka-Volterra model predicts the outcome of the competition between two species. That means it can predict who will win, who will be defeated if a competition arises between two species. Suppose two species, so species 1 and species 2, they are competing for an identical niche. So, two species are competing for an identical niche. Now, the impact of species 1 on species 2 and impact of species 2 on species 1 is known as competition coefficient, alpha and beta. So, this is species 1 and this is species 2. Now, effect of species 1 on species 2 is alpha 2-1. Effect of species 1 on species 2. So, when species 2 is killing species 1, it is written as alpha 1-2 or alpha. When species 1 is killing species 2, it is written as alpha 2-1 or beta. Is it clear? So, when species 2 is killing species 1, it is written as alpha 1-2 or alpha, and when species 1 is killing species 2, it is written as alpha 2-1 or beta. Okay. So, if you are confused about that, I am showing you a trick. Alpha 1-2, that means alpha 1-2, that means 2 is killing 1. Here you can remember that this 2 is dangerous and it is attacking from the back, because 1 will attack you always from the back. So 2 is attacking 1 from the back. That's why 2 is in the back of 1. And alpha 2 1, that means 1 is killing 2. So here 1 is attacking species 2 from its back. That's why alpha 2 1. This is a simple trick to remember. Now we need to calculate the growth rate of each species. So we need to calculate the growth rate of each species population, because if growth rate of one species is high, the growth rate of other species must be less due to the competition for the same resource. So suppose species 1 and species 2, these two are competing for a particular resource. Now growth of species 1 is high, that means huge number of species 1 are there. So if huge number of species 1 are there, definitely they will win over species 2, because species 2 are less number. The growth rate of species 1 is high, that's why huge number of species 1 are there, and the growth rate of species 2 is less, that's why low number of species 2 are there. Hence definitely species 1 will win as they have many numbers. Now when there is no competition, species 1 is present alone. Okay, so the growth rate of species 1 will be this one. So here no any competition is there, only species 1 is there. dn1 by dt is equal to r1 n1, and here in the bracket k1 minus n1 divided by k1. So this is the formula. You have to remember this formula. You need to remember this formula. So here d is the rate of change, t is the time, n1 is equal to existing number of species 1 in the ecosystem. So how many species 1 are present in the ecosystem, that is n1. r1 is equal to reproductive capacity of species 1. Reproductive capacity of species 1, how they reproduce. And k1 is the carrying capacity. It is the carrying capacity, that is maximum number of species 1 that can exist in the ecosystem. It is carrying capacity. Did you get the difference between carrying capacity and N1, that is N1 and K1? N1 is the existing number of species 1 in the ecosystem. Suppose 10 number of species 1 are there in the ecosystem currently. Carrying capacity is the maximum number of species 1 that can exist in the ecosystem. So suppose a ecosystem can accommodate 50 number of species 1, that is K1, but only 10 number of species 1 are available now, that is N1. This is the difference. So you have to remember this formula, that here species 1 is present alone, and this is the growth rate of species 1 when no any species 2 is there. Similarly, when there is no competition, species 2 is present alone. So here no any species 1 is present, only species 2 is present here. The growth rate of species 2 will be this. So the formula is same, only I have changed this 2, right? So this formula and this formula both are same when they are present only alone, the competitor is not present in the environment. So here again, D is the rate of change, T is the time, N2 is the existing number of species 2 in the ecosystem, R2 is the reproductive capacity of species 2, K2 is the carrying capacity. That is maximum number of species 2 that can exist in the ecosystem. But when both species are present, so now species 1 and species 2 both are present, and there is a competition between these two. So now the competition will arise because both of them are present. So the growth rate of one species will be dependent on other species, because I have already mentioned, if growth rate of one species is high, the growth rate of another species will be obviously low. That's why if you need to check the growth rate of one species, you have to consider the growth rate of another species also. Therefore, this equation is little bit changed. The equation will be modified like this. So here you can see till this part, the equation is same when a single species was present alone, like that, right? But only this part is extra. Now I will say why this part is extra. So here I am showing it the growth rate of species 1. So why this is extra? Alpha into why this is extra? Why this is minus from this? Okay. So because growth of species 1 will be dependent on the killing effect of species 2 on species 1, right? Growth rate of species 1 will be dependent on the killing effect of species 2 on species 1. Hence alpha, that is 1 to killing effect of 2 on 1. It is used here. That's why this alpha is used here. And it is also important to know how many species 2 are present in the same ecosystem, because more number of species 2 will have a more impact on species 1. So if more number of species 2 are present, they will kill more number of species 1. Therefore, in this formula we are using alpha N2. So N2 is the number of species 2 and alpha is the killing effect of species 2 on species 1. So we will minus this from this whole part. Then only you can understand the growth rate of species 1, because this is now dependent on the alpha and N2. Is this clear? Similarly, the growth rate of species 2 will be this. Here also till this part the equation will remain same and only minus beta N1 is added. So here also beta means beta 2 1. So the killing effect of 1 on 2 will be considered, and how many species 1 are present here, that would be considered. So that is N1. That's why beta N1 I have made it here. So I have written extra minus beta N1. From this formula we are able to calculate the growth rate of one species in the presence of other species. Now we will calculate the growth rate. See this graph carefully. So this is first case 1. I will show you 3 cases. Please try to understand this carefully. I will make it simplest. Okay. So here in the x axis and this is the y axis. In the x axis you can see number of species 1 and in the y axis this is number of species 2. So in the x we can see number of species 1, in the y number of species 2. Okay. K1 is the carrying capacity of species 1. Carrying capacity of species 1, that means how many species 1 are accommodated by the nature. K2 is the carrying capacity of species 2. That means how many number of species 2 are accommodated by the ecosystem. Now, suppose K1 is 10, K2 is 30, alpha is 5. So, alpha means we know 1, 2, killing effect of 2 on 1. Beta is alpha 2, 1, that means killing effect of 1 on 2, that is 2 here. So, now K2 by beta, K2 by beta is equal to 30 by 2, that is 15, and K1 by alpha, that is 10 by 5 is equal to 2. Okay. So, K2 by beta, that is 15, it is more than K1 because K1 is 10, so 15 is more than 10, right? So, here in the x axis you can see I have kept K2 by beta here because this is more than this. So, K2 by beta is more than K1, that is why I have written it like that. Again, K1 by alpha. So, K1 by alpha is equal to 2. It is less than K2. K2 is 30. So, 2 is less than 30. Hence, I have written K1 by alpha here and K2 is here because K1 by alpha is less than K2. Is this clear from the calculation? Okay. So, if it happens, now you can see that because carrying capacity of species 2 is here more. Carrying capacity means, carrying capacity of species 2 means K2. So, K2 is 30 here, it is here more compared to species 1 because carrying capacity of species 1 is only 10, but it is 30. And killing effect of species 1 on species 2, that is beta, that is 2, it is less compared to killing effect of species 2 on species 1, that is alpha, that is 5, right? Okay. So, now here you can understand that what will happen. Species 2 will win here. Here species 2 will win. Why species 2 will win? That is clear from here because the carrying capacity of species 2 is more compared to species 1 and alpha is more than beta. That is why species 2 will win here. Next we will see the case 2. Again here we will consider the same thing. In the x axis number of species 1, in the y axis number of species 2. Here suppose K1 is equal to 30, K2 is equal to 10, alpha is equal to 2, beta is equal to 5. K2 by beta, that is 10 by 5 is equal to 2 and K1 by alpha, that is 30 by 2 is equal to 15. Okay. Now here you can see K2 by beta, that is 2, is less than K1, that is 30. That's why here I have written like that. This is just the opposite of the previous case. So here K2 by beta is presented here and this is K1. K1 by alpha, that is 15, it is more than K2, that is 10. That's why I have written it like that. K1 by alpha is more than K2. So, species 1 will win here. So, in this case, species 1 will win because just the opposite case is happening here. Because in this case, the carrying capacity of species 1 is more and beta is more than alpha. Now we will see case 3. This is one more interesting case. So here K1 is 20, K2 is 20. That means the carrying capacity for both species 1 and species 2 is same for the nature. Both are 20. Alpha is 5, beta is 5. That means the killing capacity is same for both of them. The impact is same and carrying capacity is also same. So K2 by beta is equal to 20 by 5 is equal to 4 and K1 by alpha is equal to 20 by 5, that is equal to 4. So in the x-axis you can see K2 by beta, that is 4, is less than K1, that is 20. So I have written it like that. K2 by beta is less than K1 and K1 by alpha, that is 4, it is also less than K2, that is 20. Hence I have written it like that. K2 by alpha is here, K2 is here. So in this case, an intersect will be occurring. That means both species 1 and species 2 will win here. Both of them will win. Right? This is all about Lotka-Volterra model. Hope you have understood this thing.